Hi everyone, I hope you're having a wonderful day. I thought it'd be a good idea to make a video on map, filter, and reduce, just because I use these functions nearly every day when programming, and I thought it'd be good to try and introduce these to some people that may not have came across them. I'll be covering what map, filter, and reduce are, how they're typically used, and then towards the end I'll go over how they're actually implemented, because it's really not that complicated, and I think seeing their implementation gives you a better understanding of how they work under the hood. So what are map, filter, and reduce? Map, filter, and reduce are three commonly used list transformation functions, and they're typically part of the standard library of any programming language that supports first-class functions. By this, I mean any programming language that supports functions being able to be assigned to variables or passed as arguments to functions. They're incredibly common, especially if you're familiar with functional programming, and they're a very versatile tool. So let's jump right into it. Map takes a list and a function and applies the function to each element in the list. So let's think about that a bit using this JavaScript example. I have a function here called double, and it has one parameter called x, and then it just returns x times 2. And in JavaScript, the map function is on the array.prototype, or on the array prototype, so all you have to do is get the array and call map on it. So calling map with double just goes to the first element. It calls this double function and passes 1, which will return 2. It gets 2 and calls double, which will return 4. 3 calls double, which will return 6, and so on. And then by the end, we've transformed this array into this array by passing it a function that just knows how to transform one element of the array. And it's worth noting that the length of this array will be the same as the length of this array. You can see the Python example as well, that it's pretty much identical. The only difference is it's not on the array prototype because JavaScript doesn't, or Python doesn't have that. So you have to call it like a normal function. And also map returns a list in Python, so you have to convert it to, or map returns a map in Python, so you have to convert it to a list before you can print it out. Moving on, how is map actually useful? So it can't really be understated how frequent it is that you need to transform lists of data in development, especially in back-end software development. So it's a really common scenario where you might make a request to an API, or you might get some data from the database, but it's returned in a format that you can't really do anything with. You have to manipulate the data before it actually becomes useful to you, and this is typically known as data massaging. So if we look at this little example here, we have a list of enemies, and these objects have an ID, a name, a HP, and a type. And if we look at the name, it's all in capitals, and we don't really want to show this to users. We would much prefer if it was normally capitalized, with the first letter being capitalized and the rest being lowercase. So we need to transform this array of data, or this list of data. And we define this little update name function, which I'll go over in more detail in a second. So now what we do is we create a new list by calling enemies.map and passing the update name function. And what this will do is it will get the first element of the array and pass it to this function. And once it's been passed, it'll destructure the name out of this object. So we're saying const name equals enemy. So this pulls the name property out of the enemy object. We get the first letter of the name and we convert that to uppercase. And then we get the rest of the name and convert it to lowercase. And now we're just creating an object. And this is using the ES6 JavaScript destructuring syntax. And basically all this is saying is copy all of the properties that are in the enemy into this object. And now we're saying, let's replace the name property with our new first letter, our uppercase first letter, with the rest of the string. And this will repeat for each element of the array. So it'll go for Groznak, it'll do the same, it'll update the name. Dracoth, it'll update the name. Smitty, update the name and return it. Jerome, update the name and return it. And we can see by the end of this, when we console log the updated enemies, we have a new array where each object now has an appropriately capitalized name for the enemy. Grisnak, capital G, Groznak, capital G, Dracoth, capital D, and so on. So we've just transformed this array into this array just by defining one little function that tells you how to manipulate an individual of these, an individual object. So moving on to filter. Filter takes a list and a predicate function and applies the function to each element in the list and then returns all the elements for which the predicate function returns true. A predicate function is really just a function that returns a boolean. That is, it returns either true or false. So if we look at this little JavaScript example, we define a function called greater than 3 that takes an x and returns true if x is greater than 3 or false if x is less than or equal to 3. And now we call filter. So all this does is say it passes 1 to greater than 3, which will return false. And because it returns false, it excludes it from the return array. And it does the same for number 2. 2 is obviously less than 3, so it returns false. So it's not included. Same with 3. 3 is not greater than 3, so it's excluded. But now when we get to 4, we can see that 4 is greater than 3, which returns true, and now it's added to the array. And it's the same for 5, and it's the same for 6. And you can see in this Python example that it's pretty much identical to the map example. Filter is a really useful function, and I want to show a little example of how it can be used. So using the same enemies as before, say for instance someone asks you, okay, that's cool, maybe it has 1,000 elements and you want to get only the dragons. Well, all you have to do is define an isDragon function. It's a predicate function that takes an enemy and says, is the enemy type equal to dragon? And now all we have to do is call enemies.filter with isDragon, and this will return a list of all of these objects where the type is equal to dragon. It'll go through each one, call this, is the enemy type equal to dragon? Nope, it's not. Groznak is a goblin. Dracoth is a dragon, so it'll return true now, which will add it to the list. Smitty is a dragon, so it'll return true now, which will add it to the list. But Jerome is a duck, so it'll return false now, and it won't add it to the list. Now, whenever we console log the dragons, we can see that the only objects in here are Dracoth and Smitty. So it's a really easy way to filter it. Another example I wanted to show was a search bar. So doing a naive search using filter is an incredibly common thing. This might be searching all the rows in a table, or maybe searching products that you have in inventory. So I have this HTML up here that is just a search bar and a div that'll hold the results of your search. Let's go through this. We have the update name function that you saw from the map example. We have this little render function that just takes the list of enemies, gets the results, clears the HTML, and then for all the enemies that we've passed in, it just creates a paragraph element, updates the text of the paragraph element to the enemy's name, and then appends it to this results paragraph up here. We have this handle search function too, which I'll explain in a second. And here is where we get to the enemies. So it's the same enemies list as before. And now I'm mapping the update name just so it looks a bit better. This will render the initial list of all of the enemies. But now we're saying get the search bar and then add an event listener for input. And then whenever someone types into the search bar, I want you to call this handle search function. So somebody's typed into it, it'll call handle search. Handle search will get the search bar, get the search text that your user entered, and then it'll start to filter the enemies based on whether the enemy's name includes the search text that the user entered. And now that we have a list of filtered enemies, it'll just render it. So I can show this example here. if I type in X, nothing will be returned because none of the enemies have X in their name. But if I type G, it'll return Grisnak and Groznak, and then if I type R, it won't change anything. But if I type I, it will only return Grisnak, and that's because it filters based on whether this string includes this string. And that's just a little practical example of when it's actually used, because I've done this maybe, 5 or 6 different times for very naive searches. Moving on, reduce is probably the most subtle of these 3 functions. It's a little tricky to explain and probably a little trickier to understand, but you just need to play about with it a bit before you start to really intuitively understand it. Reduce takes an array and a function and applies the function to each element of the array, passing the result of the calculation to the next reducer call. So let me just try and explain this here. We have an initial value of 0, and then we have this little function called sum, and it takes an accumulator and a current value, and it adds the accumulator to the current value. So reduce is really just used whenever you have a list of data and you want to reduce it to one singular, like, scalar value. So say, for instance, you have a array of users that have an age property on them and you want to get, the average age. You could reduce it by adding up all the ages. So continuing with this example, we have an array of 1, 2, 3, 4, and 5, and we're calling reduce, and we're passing the sum function in with the initial value of 0. So what this does is it'll call sum with an accumulator of the initial value, which will be 0, and then the current value, which will be 1. And it'll say, add the accumulator to the current, so 1 plus 0 is 1, and then it'll move to the next value here. And it'll call sum again, but now the accumulator is 1, and the current value is 2. So it'll say, add the accumulator and the current value. So 1 plus 2 is 3, and then it'll move on. And so on. So it'll say, the accumulator is 3, the current value is 3, add these, which will produce 6, and then it'll move on. And once we've got here, it'll say, the accumulator is 6, the current value is 4, add these together, and you'll get 10, and it'll move on. And now it'll say the accumulator is 10, the current value is 5, and add these together, which gives you 15, and then it'll return the accumulator at the end. And this effectively has just summed up this array, so 5 plus 4 plus 3 plus 2 plus 1. And we've transformed this array of numbers into one value by reducing it using this sum function. And as you can see, the Python version is pretty much identical. So yeah, that goes through a lot. Let me just skip forward. So how is reduce useful? Using the same list of enemies as before, we can see that they all have a HP value. And maybe somebody asks us, okay, I want to get the mean HP, that is, add up all these HP values and divide them by the number of enemies there are. So all we have to do is define a sum HP function that has an accumulator and takes an enemy object, and it'll return the accumulator plus enemy HP. And this just will sum it up. So it'll say 10 plus 50, which is 60, plus 500 is 560, and so on. And at the end, it'll produce this value of 1,360. Now that we have the total value, all we have to do, this will go through it individually. So the accumulator will be 0 here, and the HP will be 10. So 0 plus 10 is 10. Now it'll be 10 plus 50. 10 plus 50 is 60. Now it'll be 60 plus 500, which will be 560. Now it'll be 560 plus 300, which 760, and so on. Sorry, it took me a second there. And when this is all calculated, it produces this value of 1,360. And now all we have to do is just divide the total HP by the length of the enemies array. And this will give us a mean value of 272 for the HP of this entire list. Now at this point, you're probably asking, okay, this seems a bit hard to understand, and I can replicate this functionality with for loops fairly easily. Like, what's the benefit of doing any of this? But I think the real benefit comes from really putting them all together. So in this example, and this is a bit of a contrived example, but say for instance, you have a boss or a project manager and he said, I want you to get all the dragons, multiply their HP by 10 because they're way too easy at the moment. And then I want you to get the mean of their HP after it's been multiplied by 10. And this sounds a bit contrived, but I've had to do equally contrived things in actual real world programming. So if we go through this, we have the isDragon function. We have the total HP function from the reducer example. And we have a multiply HP by 10, which we'll use in a map. And then all we have to do here is say the dragon average HP is the enemies. Filtered by are they a dragon? So this will return just the dragons. This will multiply their HP by 10. This will sum their HP and then divide it by the amount of dragons there are. And it produces 1600. I've noticed there might be a bug there. Yeah, leave it in the comments. So how are these functions actually implemented? Reduce is a bit complicated. Map seems a bit simpler. Filter seems simple too, but they really aren't magic under the hood. They're very simple to implement functions. We can look here as examples of how to implement them. So map is really just a function that takes an array and another function. I create a list of results and I iterate through the array that was passed in. I get the current item and then I just call the function with the item and push it to this temporary array, and then I return the array. If we look down here, the double is pretty much exactly the same as the first example I showed you. I create a double function, I pass this array in, and it produces an array of doubled values. As you can see here, map is just going through each element of an array and calling a function, passing it as an argument, and then returning the result. Filter is pretty much the exact same format. I take an array and I take a function. I create a temporary results array. I iterate through the array that was passed in, get the current item, and then I say if the function called with the item as an argument returns true, then push it to the output result. And then I've just used the exact same example from the filter. I'm saying const greater than 3, x greater than 3, and then I pass in 1, 2, 3, 4, 5, 6, and it returns 4, 5, 6 as they're the only values that are greater than 3. Reduce is a slightly more involved implementation, and it's a bit trickier to understand, but hopefully it'll make sense. Reduce takes an array, it takes a function, and it also takes an initial value, because you really want to, you either pass in an initial value for the starting value of the reduce function, or it uses the first element of the array. So the accumulator is saying, did we pass the initial? Like, did somebody pass the initial argument? If they did, just use that as the initial. If not, use the first element of the array. And then we're saying the start index is, did they pass an initial argument? If they did, then just use the first element as the starting index. Or if they didn't pass an initial, it means that we have to use the first element of the array, in which case move it forward by 1 because we don't want to calculate that twice. Now all we have to do is iterate over the array by doing let I equals the start index, I less than array.length, and then we just update the accumulator. We say the accumulator equals the function whenever we pass in the accumulator and the array value. And then we return the accumulator. The accumulator is what keeps track of the reduced value. In functional programming languages, this is typically known as fold. It can be like full del or full right, which has different ways of approaching it. But you can see here that our reduce acts pretty much identically to the reduce implemented by JavaScript. So that's everything. Hopefully that was a little bit clear. I'm not sure how well I came across. If you have any questions, please just leave them in the comments. And if you think you learned any from this, like, comment, and subscribe. And thank you for watching. I hope you have a lovely rest of your day.